quick background about myself. I grew up on a organic farm here in Massachusetts. My parents ran the local organic farming organization called NOFA, Northeast Organic Farming Association, for about 35 years. So I've got a background in that wing of the movement. And when I got married and had found no better lifestyle than the homestead to raise a family on, rapidly realized that my skills were not sufficient to make a living on the homestead. And I sort of connected dots and said, maybe, it's because my plants are being attacked by insects and disease that I'm not able to make a living. Maybe if they were healthier, I could make a living. And I had always thought about organic being a, superior than quote unquote conventional. And I think in many ways it is, and that you're not using toxins and things like that. But just because you're not using toxins does not mean you're producing crops that are nutritious and healthy, as evidenced by nature's report card, insects and disease. You look around in nature and you don't see crops being taken out that way, but in your agricultural zones, oftentimes you do. And that actually, I think, is a really important insight about who's fit to eat that. And I have long rants I go into about, what kind of a digestive tract we have and what kind of a digestive tract, larvae have, and fungal pathogens. But functionally, it's very interesting that it correlates with flavor. So when a plant is growing well and is indigestible to insects and disease is exactly when it has high levels of flavor and aroma, which is what makes it compelling for us. And so it was through the Acres community where I met Vincent and met Jerry and many, many other elders 15 years ago that I began to sort of really identify some small changes in technique and practice on my farm that could get those beneficial results of increased yield and vigor and vitality and pest and disease resistance and farm viability. It came to me that if I had grown up on an organic farm and my parents had run an organic farming organization, and a lot of these principles and techniques that made the livelihood much more viable were things that I had not been exposed to, then perhaps others as well were not exposed to them. And so that started a process of teaching effectively, workshops, courses, seminars, and things like that, which turned into an organization around 2010 called the Bionutrient Food Association, whose mission has been to increase quality in the food supply. And by quality, we're talking about flavor, aroma, nutritive value, health-giving attribute. And so we've been focusing on this topic for a decade now, and started off by sort of bringing out the concept in a more active way that nutrient variation exists in food. People have had the experience perhaps of buying a grocery store tomato in January and maybe eating a ripe tomato off the vine in the summertime, and that variation in your mouth of flavor, and that is a variation of nutrition. If you've eaten a peach off of a tree when it was ripe, or a peach that came from the grocery store, milk, it doesn't really matter what it is. We are actually wired for discerning what's good for us and what's not. And when something doesn't have a flavor or has a repugnant flavor, that's nature telling us it's not good for us, even though it may actually have an organic label on the package. So long story short, we've been doing courses and conferences for about 10 years. All of our work is freely available on the internet. We've recorded every single presentation at every conference. All of our 2-day courses are freely available. We've been trying to sort of take this insight from the biological perspective and keep it alive, keep it fresh, identify who the cutting edge voices are, engage them. And so for those who have time to listen to podcasts or whatever it is in your personal life, you've got a downtime or free time, please do feel free to access that wealth of wisdom that I think we've been curating now for a decade. I don't think that's the topic for today's presentation, but I do want to say that is there. So as our organization spread through primarily through word of mouth, starting in the Northeast, and then further and further across the country and then to other parts of the world. Um, Part of the pitch or the vision was not just that, you as a grower can have better economic viability and be producing crops that are more nutritious and in line with what a grower should be doing, which is producing food, not volume. Um, but that the opportunities to systemically address things like chronic illness or climate irregularities are at our fingertips, that through a more appropriate relationship with land, one which I would say is ideally guided by the indigenous perspectives globally, but can be supported by Western scientific data as well. um, I would say should be guided from within and communion with land, but we don't need to go there necessarily right away. um, you know the opportunity to systemically address what appear to be existential global crises is at our fingertips. If we shift the way that we do farming, we shift the way that the land is engaged with, we shift the nature of what's in our food, we shift the nature of ourselves. You eat junk and you become junk, you become incoherent, you become dissonant, um, you became unable to tune into your higher nature. I would suggest politically, economically, environmentally, you know the education system, the media structure. We have all these systems in place which are not in harmony. And I would say, instead of fighting them and trying to sort of push back, let's stop and stand back and say, maybe it's because the people who are creating those systems are incoherent in themselves. We can see the decrease in nutrient levels that has occurred in the mainstream supply chain over the last 70, 80, 90 years, as documented by the um, USDA and the British government and the German government and Japanese government. Globally, we've tracked these things. Um, we understand epigenetics. We understand when you don't have certain key nutrients in your body and your body's going through this process of basic replication, you don't have the enzymes, then you have breaks in the DNA. We say that there's chronic disease like diabetes is connected to genetic markers. Well, those genetic markers come from functionally chromium deficiency. Um, you don't have the nutrients in your body because they weren't in your food for your body to function as it needs to, and you begin to break down. Well, you get a new body every 6 months. Your cells are rebuilding themselves. Um, your bones may take 7 years, but your blood takes 2 weeks. On average, you get a new body every 6 months or so. If you are eating food that is nutritious, your body heals itself. Your coherence increases. So there's some really interesting opportunities there on the human side, but also on the environmental side. The working with nature in that more of a polyculture manner is the way to balance the climate, is the way to harmonize ecosystems. And agriculture is the largest footprint that we have on the planet as humans. So our thought was, how do we drive the systemic shift towards these agendas, right? Presuming they're not too grandiose and beyond people's thought about being able to actually have an effect. Our basic insight has been that it's the economic system which drives a lot of activity in the world. Money determines how people act, how they engage. Lack of money, access to more money, etc. And so our thought has been, is there some way we can align economic incentive with these broader ecological and human health outcomes? How do we apply an economic driver where growers are supported for growing food that's more nutritious, that is more in harmony with the land, where consumers have the ability to choose that food which is best for themselves and their family? How do we apply that economic system? And I grew up on a farm, but also watched my parents help write some of the first organic standards here in Massachusetts in the mid 80s. I watched the certification of organic turn into a national thing that effectively, I would say, has been co-opted by industry. And so, we've watched labels and certifications over time lose their honor and integrity and meaning. And so, I would say it's nice to be able to say something, but foundationally, if you're looking at a label, it's a binary. It's a you are organic or you are not. You are non-GMO or you're not non-GMO. There's all kinds of excitement and passion amongst various industries to focus on a regenerative standard. This is regenerative. This is not. I mean, we understand that from a foundational standpoint, life is not binary, right? There's alive and there's dead, but there's there's a massive continuation of vitality between full health and dead. And so it's like that with a carrot, it's like that with a cucumber, it's like that with beef. There's a massive variation in the nutrient levels in crops that are produced, that are on the shelf. And so we need some way of discernment that is not a binary, you are or are not good, but you're in the 80th percentile, you're in the 40th percentile, you're in the 20th percentile. So that's was part of our understanding, is that we need to frame it in a way that's honest. And ideally, we want to be getting away from the label, and we want to go to a framework where people can engage in direct perception. I use a couple metaphors here. One point I want to make is that obviously, from a nutritional standpoint, our tongues are our best nutrient meters, and our nose, right? We're wired for that capacity, but we want to basically move away from a you have to trust the label system to a you can directly perceive system. So long story, roundabout, some of the concerns and the concepts around our work, it was about, I think, 2016 or so, when we felt like we had achieved enough momentum as an organization to seriously step into this process. We had helped to popularize the term nutrient density, to convey this concept that variation existed in nutrient levels in food. It wasn't all uniform like the USDA label says. But the basic concept was, we want to be able to build a handheld meter that a consumer or anybody else in the supply chain can use in real time to flash a light at a carrot, flash a light at a cucumber, flash a light at beef, and see what's in it, how good it is. So I will just show you right here I'm not sure how I can get it to show up in this there. This is our second generation calibrated spectrometer, that you put the lettuce or the carrots or the wheat on it here, and you flash a light and it spits out a reading. It tells you antioxidant levels are in the 84th percentile, the BQI is in the 60th percentile. So the concept is, we want to give people the ability to assess directly in real time, transparently, open source, flash of light, non-invasive, relative food quality. We think if we can provide that capacity to people to choose what's best for themselves and their family, what will taste better and cause them to be healthier, that they will choose that some significant subset of the population will begin to choose that, which will incentivize the supply chain to focus on quality as opposed to volume. I use the example of, milk companies. We've got probably, 2 or 3 major milk companies here, at least on the mainland. You've got, Stonyfield or maybe Organic Valley. There's Horizon. What the cows ate determines what's in their milk and relatively how good it is for you. And so if you had, say 50 people with one of these meters, and they were out there, buying one of each of those jugs of milk off the shelf and testing it, and then uploading that reading onto the internet, our thought is, I don't care which company it is, we'll say it's Organic Valley, we'll say when Organic Valley is better in general, that starts leaving the shelf, and Stonyfield stays on the shelf, and the Horizon stays on the shelf. Our thought is that Stonyfield and Horizon are begin focusing on maybe ensuring a better diet for their cows, so that in 2 months or 6 months, as people keep testing, they'll find, oh, actually now Horizon is better than Organic Valley. Let's start buying that. And so establishing that dynamic where there's a competition to improve function based on inherent nutrient levels. That's the basic idea across the board, whether it's beef or cucumbers or rice or, ginger, whatever it is, establishing that kind of a framework. So we started this project. We identified 3 things that we think we need to do. One is to be able to build a meter that can do this. Is it possible to have a handheld, consumer-priced spectrometer that you can calibrate the nutrient levels in food? That's one question. Second question, what is the variation in nutrient levels in food? And can we define that? Can we characterize that? Can we see what, because before you say this is better, this is worse, you have to understand what good and bad are. So step 2 is define that variation. And then step 3, what are the causal dynamics? What environmental conditions, which management practices, what fertility programs, which cultivars, which, what are the epigenetics, what are the microbiome dynamics, which permaculture function systems correlate with those nutrient variations and correlate with the soil carbon and soil biological activity, et cetera. So what is quality? What causes it? And how do we test for it? That was our agenda. And we started in 2016 and identified some partner organizations and individuals who had the skills to do things that we didn't have as an organization, to build meters and to build software sets and to build apps and things like that. In 2017, we got our first donations sufficient to build the first generation meter. In 2018, we started with building our first lab, and we tested carrots and spinach, and we found dramatic variations across the board, at least with the nutrients we were looking at. I think about 12 elements and a few compounds. So we'll say this carrot had as much calcium in it as those 3 carrots, or this leaf of spinach had as much iron in it as those 16 leaves of spinach, or this carrot had as many antioxidants as those 200 carrots. So that would be 3x or 16x or 200x variation, right? Massive, not 10% variation, 10x variation. That's what we found in the supply chain. We asked people to go to grocery stores, to go to farmers markets, to get organic, to get not organic, to get, and we get samples in from all over the country. And in 2019, we added another lab at Chico State in California, and we added 4 more crops. We added lettuce and kale and grapes and cherry tomatoes. And we worked with a few dozen growers to document their fertility programs and management practices and asked them to send in the soil to the lab along with the crops they harvested, so we could begin to connect those management practices and environmental conditions with soil metrics, with nutrient variations. We again found that massive variation, 2x, 5x, 10x, 20x, 50x, depending on the element, depending on the compound. That was the variation in the crops. And then in 2020, added our 3rd lab in France. We went over, maybe like 150 farms we worked with. We tripled again the number of crops, over 20 we looked at. So added potatoes and beets and, Swiss chard and leeks and squash and apples and blueberries and oats and wheat, almost a couple dozen different crops that we assess. And again, across the board, very significant nutrient variations. And we, through the work we accomplished in 2020, had enough data to be able to calibrate now this meter. So the first thing to do was like, can you build a meter that you can flash a light at something with and get a reading back? Yes. Now, can you calibrate that meter? So can you get this metadata and make it so when somebody has one, they flash the light at the carrot and they get a reading back. So now we have calibrations with this meter for 10 crops for those nutrient variations. We have data that shows direct connections between what we would call biological or regenerative or organic type management practices and increased soil carbon and increased biological activity and increased nutrient levels. And so, I've got a couple slides I can just show with some of those results. I think there was a request earlier to do that. So let me just see if I can share my screen for a moment and walk through those slides. Here we go. All right, so I got to go back to the beginning. All right, so to tillage and soil organic matter in wheat. So 0 to 10 centimeters, which is about 4 inches. Light tillage decreased organic matter by 20%. Heavy tillage decreased organic matter by 30+% at that top 4 inches zone. And then subsequently as well, light tillage decreased at 15% or so at the 4 to 8 inch zone, and similar 30 or so % decrease with the heavy tillage in that zone. So direct connections, this is, I think it's about 50 farms, average farm size about 3,000 acres. So heavy tillage greater than 66 inches depth, antioxidants dropped 75% in that week. Polyphenols dropped 35%. Proteins dropped 40%. Magnesium dropped 70%. Calcium dropped 50%. Iron dropped 50%. You can see these dramatic decreases in nutrient levels that correlate directly with those management practices, right? Significant numbers of farms, significant acreage across the US and Europe. Really nice connections there. The variation in nutrient levels by RDA, so recommended daily allowance. The concept is that there's X amount of copper in wheat and X amount of zinc in oats. Well, we found that variation, and so we try to characterize that in a way with, we'll say calcium and wheat. The minimum was 5% of your RDA you can get from one serving of wheat, and the maximum we found was almost 13%. But let's look at iron, 25% to 80%. Magnesium, 0.01 to 30, right? Phosphorus, 3.5 to 60%, right? A 20x variation in phosphorus. Zinc, 0.01 to 34, right? And people know about zinc and stunting globally, hundreds of millions of people globally. There's these arguments about genetic modification and how we can, through genetic modification, we can cause crops to have more nutrient levels. And that's an argument for genetic modification. People may have heard about golden rice. There was a bunch of PR around that. What we're showing here is management practices, simply how you treat the soil, the quote unquote regenerative or the biological, the agroecological, the permaculture, whatever your word is, those management practices that cause life to function more well correlate directly with dramatic increases in nutritional value in food. This is by RDA, so try to frame it in a sort of conventional approved USDA mindset. And this one is also very interesting, showing the connections between farmers working together to push the envelope and results. So this is what does it say? 300 wheat samples from 50 farms, 38 in the US, in 11 states, and 12 in France. This is all the farmers that were not part of this group called Shepherd's Grain. This is where their numbers sat from antioxidants and polyphenols. And then we've got Shepherd's Grain, right? So this is a group that's actually focusing on those management practices that correlate with life functioning more well. And look at where the numbers reside, right? Across the board, the farmers that are working to push the envelope just show better results. Like they're a collective that is working together, learning from each other, managing together. They show that we can come together and we can push that envelope. So I just think this is really exciting. We've got lots and lots of data, lots of reports, long, they're called briefs, but they're like 150 pages long of graphics and details here to tease anybody who's interested. Bionutrientinstitute.org would be the appropriate website there. So that's all I wanted to share there for slides, and then go back to the sort of maybe in the last 5 minutes of introduction, where are we at now, where are we going forward from here, and then open it up to conversation. So our general concept is that for the past 5 years, we have been working on, and I would say completed now, the proof of concept. Is it possible to build a handheld consumer priced open source, calibrated meter for testing nutrient levels? Yes. Is it possible to define those variations in nutrient levels? Yes. Is it possible to connect those variations with management and environmental conditions? Yes. Do those connections look like regenerative, i.e. biological management, correlates with better organic matter and better nutrient levels? Yes. These are all things that, previously people were conveyed skepticism about. I don't know if you can define variation. I'm not sure how much it is. I'm not sure. Does it really connect with management? You can't build a handheld, spectrometer, a consumer spectrometer. That's not possible. We've done all these things, and we, as a charitable educational organization in the commons, have done them all open source. Everything's in the commons. There's no IP. There's no investment. There's no control here available. It's all been through donations. And that's a really important point I want to make as this conversation goes forward, is about, the integrity of the information. And we've been very passionate about keeping it in the commons and not providing, any means by which it can be controlled going forward. As I mentioned earlier, my experience with organic and, industry and the government, and how that has trended over time. So now we feel like we've proved concept. It is possible to do these things. We've got a reputation, and it seems like there's an openness to these ideas. So now we're going to try to actually define nutrient density. We have defined variation in 15 metrics: copper and zinc and calcium and potassium and antioxidants and polyphenols and protein. We can say this is the range. We can say this carrot has more, that carrot has less, but we aren't saying this carrot is better and that carrot is worse, right? To be able to make that kind of a statement, honestly, would require much more data than we've collected thus far. And so that's our next step. Is I'm saying in the next 3 to 5 years, we have defined nutrient density for the world's top 20 crops, the things that are sold in most dollar value. So we're starting with beef. Beef, there's more dollars spent on beef than any other crop on the planet. There's more acres spent, producing beef or used to produce beef than anything else on the planet. And there's actually a bunch of really good growers who are, doing a good job and looking to identify, to be able to differentiate themselves in the market based on, my beef is better than that CAFO beef. And so that's our first one. We're saying it's about $1 million per crop to do. And so, those who are interested in engaging, again, bionutrientinstitute.org, I think it's /beef. We'll give you the links there. But broadly, we're engaging in this process of, building the framework whereby everyone can see and everyone can engage. And it's not just the consumers, it's the growers as well. Any grower who takes part in the data collection process, they record their fertility programs, their management practices, their environmental conditions, their cultivars, their, microbiome dynamics, their proprietary information about, like, my name, my address, my farm is entirely private. Like, no one has access to that. That's your data. But what we are doing is saying, if you're going to take part in this process, we expect that you will share your metadata. You share the environmental conditions, the management practices, the soil metrics, and the nutrient levels, so that of the 800 carrots that we've got from around the world, we can see this variety seems to do better. This variety seems to do worse. This fertility program seems to do better. This fertility program seems to do worse. This, we can share globally, openly, categorically, what are the environmental conditions and causal factors that correlate with increases in nutrient levels and decreases in nutrient levels, so that any grower who wants to can be a part of this and access this information, not have to trust a fertilizer salesman or a agronomist or whatever, but for the global commons to be able to have access to this information. So there's much more going on. I've spent longer than I told you I would with my introduction. Thank you for staying on, I guess. And maybe Vince wants to come back on and we can engage a conversation.
Thank you, brother. And wow, we're all not getting out of here alive, but why push it, right? And having a opportunity to quantify our food nutrient value is such a game changer, Dan, and I really appreciate this this cutting edge work you're doing. Do we have some questions in here, Katie? And I don't know why my camera's not working, but let me see. Oh, now I know why.
Vince isn't the host. It's me. You're trying to start my camera.
Okay, so we have a question from the table here, and then we'll go to the Q&A from the online. Yeah, Gail.
Yeah, aloha, Dan. This is Gail from Big Island, Hawaii. What a great project and instrument. I know my husband's totally stoked. He puts way too much in the soil, for my opinion. But you talked about the meter. Is it going to be able to actually measure in terms of units, or just percentages based on the accumulated database, or can it do both? Because I think if it could do both, that would be super helpful.
Right. So a very good point. I like to say that what we have now is an Apple II. Metaphorically speaking, if anybody knows what an Apple II was, in 1982 or 84 or whenever it came out, it was the first personal computer. It was very, very rudimentary. If you weren't a coder, you couldn't, it had no value to you. And even then you couldn't do much with it. And now we've got iPhones, right? And in between there was the Macintosh and the MacBook and things like that. So what this can do is only, where is it? There we go. What this can do is, through algorithms, give you a prediction of the level of these things, antioxidants or polyphenols or BQI. It does not have the capacity, this one, to give you direct, like 4 parts per million or whatever. It's but it's proof of concept. It's not final market ready, global, mass producible, the thing. I would say I don't expect that we as a small educational nonprofit organization are going to be in a place to compete with Google and Apple and Samsung in putting these sensors into people's smartphones, which is where I do think it'll end up. And I don't particularly want to compete with Google or Apple or Samsung. I would be very happy if they did put new sensors into their smartphones, and if they're going to inspire people to buy new smartphones so they can have access to the sensor, more power to them, more profit for them, so be it. What I'm passionate about is that the calibrations that those sensors are, the reading that sensor gives out is one that is based on the data that we've collected. So this is a first.
Sorry. Yeah. So, but the logarithms are could actually predict a unit, because
that's where we're at now.
It's based in units, and then you could actually not just do percentage RDA. You could actually have a predicted unit for each one of those items that you're measuring. And I was just thinking that actually could be as helpful as well as the percentages, but the long conversation more robust as more data is being collected.
I think, the real question, I was having this conversation earlier with someone, talking about, well, how are we going to market it? How are we going to, label it? How are we going to give the readings out? We don't know what nutrient density is yet, right? We don't have the database populated to be able to say this is better, this is worse. And only when we've got that and we know which the compounds are that are the relevant ones to be assessing and what the concentration ranges are, will we know how to engineer an instrument that can test for those things. So it's a process. I call this original research. Like, we don't know what nutrient density is. We know that nutrient variation exists and it's massive, but we don't actually have a first generation answer for what is better beef and worse beef. We've got some pretty good ideas, but we want to be going through the process honestly and transparently. And then from that point, you begin to be able to have the meters that can be out there in consumers' hands. So it's a process, as the biodynamic people would say.
So Dan, in that spirit, you've come a long way, man, and really admire and appreciate where it's at. Just in to be able to quantify, as a farmer, and to hear that practices affect as we know, in a sense, in our heart of hearts, but at the same time, to see it quantified is really heartening. As farmers, I think National Farmers Union stated that we're getting like 9 cents to the dollar on our production, and overproducing our lands, just attempting to make a living. And unfortunately, then we become slaves to our farms because we're not really making the kind of money that our efforts and putting in there would be indicative of. So, I want to find a, right with you, Cap. Let me just see what we got here. Is there questions, Katie, from the general population that's tuning in? And then we go to Kat.
Yes. Yes, absolutely. There's a couple questions in the chat feature, Dan. They're kind of long. I don't know if you can see them as well.
Yeah, I'm looking at the first one from Ramona about soil samples. Where can you send them locally? I'm not the guy to ask. So you'd have to talk to somebody else about that one. So, I mean, I can talk about soil tests, and go off, but not answer Ramona's question. There should be a grant funding for soil tests. That sounds like stuff, again, that's not necessarily pertinent to me. Maybe someone else from the organization can speak to those dynamics locally.
And I had a question I watched one of your videos and you were talking about that, I want to get this right. The physics is the vibrations of chemistry. And so that's how your meter is working off the light measured. It's measuring the vibrations that then tell you the chemical analysis.
What the hell is a spectrometer and how does it work?
Great question.
What is spectroscopy? Yeah, I jumped over that. Sorry. My intro was a little bit more rambling than sometimes it is. So spectroscopy, I'm not sure if people have heard of this idea that, we know what Alpha Centauri is made up of. We know Alpha Centauri is a star. It's pretty close. It's only a few light years away. It's, 51% hydrogen, 48% helium, and 1% other gases in certain levels and ratios. And like all the astrophysicists are like, yes, we know this. There's not really any question about it. You might ask the question, how far, how do we know? How do we figure that out? Because the Voyagers, Voyager 1 and Voyager 2 that got shipped out 40 plus years ago are, 12 light hours away. Like we've never gone somewhere and sampled a star. How do we know what something 4 light years away is made up of? And the answer is that every element in chemistry is a vibration in physics. Every compound in chemistry is a vibration in physics. Copper vibrates at a certain frequency. Zinc vibrates at a certain frequency. It's like and that vibration is light. So what happens is we take a picture of the light coming off of the star and you parse it out and you say, oh, that's the frequency of hydrogen. That's the frequency of helium. So you don't actually have to go to the star to sample it to get a reading on what's made up of. If it's decades old science, and it's called spectroscopy. So our basic point is, if we can read what something, many, many light years away is made up of, and a light year is a long distance, then why can't we read what something a millimeter away is made up of, right? So all we're doing with the spectrometer is you're flashing a light at the carrot or at the beef, and you're taking a picture of the light that bounces back, and you're looking in these certain frequency ranges. And so we can connect this color light that came back with this element in this compound, and that color light that came back with this element in this compound at these levels. So yeah, thank you. That's a very basic question, but it's a foundational understanding, I think, that I should have conveyed earlier. So
Kat, you got a question?
Yes, I do. Thank you for your work. First of all, with the combination of information that you've actually gathered thus far, what is the most conclusive reasoning you could say for a farmer to actually practice? Like a William Albrecht's model of a great nutrient-dense soil is something to base on, but how is it that the data you've collected, what does it point to? Maybe you can't qualify it across the board, but how does it point to what practices and what we should or could be doing as a nation to really improve our food quality in our farmland. Is there any
Well,
indication at this time?
Yeah. It sure seems like the function of the microbiology is what correlates with the results most clearly. So, how sophisticated and vital is the bottom of the food chain? That really is what is, determinative in the relative quality and health of the plant. So some people might say, well, that means you should add more compost tea. And I would say, if a microbial deficiency is your issue, then sure. But, microbes also need water to drink and air to breathe. And so if your soil is tight and there's no air, then you can add all the microbes you want. You can put all the minerals down that you want. If you don't have any air in the soil, then the microbes aren't going to be able to breathe, and then the system's not going to work. So, it really is about the understanding that it is a biological system, that the plants are not the bottom of the food chain, that the microbes are the bottom of the food chain, and managing your soil in such a fashion as to create a dynamic where they're flourishing, which generally means polycultures, generally means soil cover, generally means minimal or no disturbance, generally means good mineral balance, and so different farms, different size scale operations, different geological dynamics, different, historical management practices. There's tons of nuances there. And, I like to say when I'm teaching my course, our job is not to control the environment. Our job is to understand what nature is needing and to provide that and get out of the way. And the question should be, when making decisions, how does nature do it? Does nature do monocultures or polycultures? Does nature do bare soil or covered soil? Does nature do, et cetera, et cetera, et cetera. So, sorry if that's not a simple answer, but hopefully worth something.
Hey, Dan, what is the, Katie, is there any other questions in there? I can't see it for some reason.
Yeah, we've got a question on the Q&A. Does the meter appear to have the potential to measure contaminants or undesirable substances in food?
So toxins, there's nutrients and there's anti-nutrients, right? And, if you're talking about beef, it's the omega-6, omega-3 ratio. It's so you want it to be closer to 1-to-1. And I think the American Heart Association says anything over 4-to-1 is bad for you. And some beef is 40-to-1. So, that omega-6 to omega-3 ratio. In general, toxins like, chemicals and things like that, herbicides, fungicides, are present at the parts per billion level, sometimes parts per million. Is it possible for a handheld consumer price spectrometer to be able to test for glyphosate and atrazine and DDT and dicamba and everything else? Yes, 100%. Is that the one we've built right now? No. Was it possible that one could be out, in 2 years? Yes. How much would it cost right now? Probably more like $5,000 than $350. But that would be the first generation of that, and then they could come down from there. So the ability to have literally in our fingertips, the ability to discern, some empirical dynamics about the world around us is amazingly potent, I think. And I like to say, when we first started with smartphones, a lot of people might have thought, well, it's basically a phone. I can just walk around with it, and, maybe I can check the internet too. And now 10, 12 years later, like, culture and society have been revolutionized by these things. So when we're talking about a handheld spectrometer, initially we're talking about it for food quality, but think about it for water quality. Think about it for point source identification of toxins in the environment. Think about people being able to assess any number of things in their environment and to self-organize around them with those empirical numbers that our culture seems to think are important, right? we may have intuitions about things, we may have internal knowings about things, but if you don't have the quote unquote data in this culture, you can get poo-pooed, sometimes quite readily. So not that I'm a big fan of technology. I'm actually a bit of a Luddite and pretty proud of it. But I do think strategically to have this kind of capacity at our fingertips to be able to say, this is reality in an empirical way, does provide the ability to have a global movement of self-organization and empowerment. So bit of a rambling.
Is there another question there? Katie?
What's that?
Yeah, someone, Kauai Aloha Farms, everyone in the chat, they put a great soil test resource on Island. So everyone should check that out. Thank you so much. Mike asked, Dan, good to hear you are working with beef. Are you in touch with the Grass-Fed Association?
I presented to, I think it was the Grass-Fed Alliance earlier this week. I've had a couple conversations with the Grass-Fed Exchange. I think there's American Grass-Fed Association. We've definitely talked to Savory a few times. So there's a bunch of different organizations out there, and I'm actually not. I don't live in that space, so I'm still trying to track out all the members of the ecosystem. We're certainly wanting to collaborate with the entities that are there. We don't want to run this thing. We want to hold space for it to happen. We think beef is important. We think nutrient density is important, and we're looking to collaborate with those who are in that world and agree with us. So I'm not sure which organization you're talking about, Mike, but if you have introductions and you want to make them, I'm very open.
Your explanation of the instrument and it just speaks to the fact that we're vibratory beings, so it would make sense that the vibration coming off of a star could be measured, and it's so nice to know that this is connecting into our vibratory being, that we could in a sense not only as consumers be well, but also as producers get the respect and recognition when we're putting so much time and energy into growing our soils.
My experience as a farmer was that, growing up on an organic farm, we struggled to make a living. And I talked about, pests and disease and things like that. And when I started to apply some of these biological principles, pests went away, diseases went away, yields went up, cost of production went down, farm viability went up. Like, people talk about a premium, a cost premium. This is only going to be for rich people. My experience as a farmer is it costs me less to grow food that's healthy than it does to grow food that's not healthy, right? Nowhere in nature are people adding fertilizer, right? You don't have to add fertilizer when you're working in a biological system, because nature has this thing figured out.
About that, Drake has a question too, but to that point, Jerry Brunetti used to say to me, you guys are out there in Hawaii trying to grow European plants without European soils. So, the whole mineral matrix of what's available to us here is different than what you have available there on the mainland. And how do you see addressing that?
Well, I guess with a few steps, if you want to eat a carrot, then, give people the ability to discern the best carrot. I think most, or a lot of indigenous cultures, I can't speak to them all, I haven't studied them sufficiently well, had many more perennials in their diet than we do. And, it does seem like those perennial ecosystems are the ones that are optimal for producing nutrition. Perhaps as we begin to characterize the full potential of what a carrot could be and what the full potential of another kind of a perennial root could be, we can say, look, you just don't get as much out of a carrot as you get out of this. If we can say, they're nice, but they're just never going to be what this is, then we can use that data again to push towards in that direction. I don't know. I mean, I'm not biased personally towards annuals, towards perennials, towards all these things. I just say, like, within tomatoes, there's amazing variation, and most of what's out there is junk. And so if that's what you want to be growing, you can probably be at the peak of the curve fairly readily. So I'm not dogmatic. Thou shalt be a vegan or a vegetarian or eat perennials or eat annuals. All these foods, come to us more like junk or more like food. And being able to discern and make decisions, I think, is what we're trying to accomplish. And let that.
Great. No, thanks. I kind of got a little off there, but I just wanted to point out that, in our ability to test going forward, we've got to make sure that we are able to concentrate the elementals that those plants need and have available those minerals and such in our.
I mean, certain things came from Asia, certain things came from South America, certain things came from Africa, some things came from Europe. I think you can tune your land to the crop you're producing. And in part, you do that by putting the plant back in where it was last year. The whole microbiome conversation about, as an organic farmer, I learned about rotations and told that you should move the potatoes every year and move the onions every year. And my thought is, if you've got the microbiome of the onion in this bed, wouldn't it make sense? And the onion seed maybe is likely to fall where it grew in nature. Then wouldn't it make sense that you would want to have the colostrum of the mother there when the baby is born? Right? I mean, I think there's a lot of things we do which are kind of ignorant and just show a lack of understanding. But maybe
Great perspective. Great perspective.
we're leaving the meter conversation.
Great.
So Dan, can you speak to the difference between using a refractometer and like how that's like invasive? You have to cut the fruit to get the sugars versus this technology, which is non-invasive. And then also kind of second question to that is, what would that $1 million per crop do? What kind of analysis do you have to do that's external to this device to have that happen?
Perfect. Those are two really good questions. Yeah. So the refractometer is, still the best instrument we've got that's broadly available and inexpensive for anyone to get a number about the value of food, right? It's whatever it is, 200 years old at this point. No batteries required. Just don't drop it on the cement floor and you can keep using it 10,000 times. Costs $30. So a refractometer is a very valuable piece of kit. The way it works is you take a piece of whatever it is you're testing and you squish it and you get a drop of juice onto the lens. And then you see like how much did it cause the light to bend. And the more the light bends, the more stuff is in the juice. And that roughly correlates with flavor, aroma, health-giving attribute, pest and disease resistance, all kinds of these other things. The biggest problem with bricks is that no one's ever done all the scientific research to prove that it's true. Like we have lots of people around the world who've tried it, and used it to great effect. But what does a 10 bricks on a carrot mean empirically as far as nutrient levels versus a 12 bricks on a carrot? I don't know of anybody who's actually done the work to define that. And so, there are infrared refractometers. You can, flash a light at something and get that same bricks reading. So there are ways of doing bricks that's non-invasive. It is a valuable tool. I think, to be able to enter the market with a serious standard, we're going to have to engage in the Western rational conversation about nutrients and vitamins and minerals and compounds. That's just the framework that people have been trained to think in, and that's the way the USDA works. And so we're going to have to be able to say copper levels X, polyphenol level Y, protein level Z, to be able to have a serious standard that's respected. So yeah, I definitely think refractometers are valuable, and with most crops will give you effectively a better reading than our meter will, because our meter only works on 10 crops. So still a valuable thing. As far as how would the $1 million get spent, I'll just use beef as an example. So what we're doing with the growers for beef, and this is a global campaign. So we've got it set up so you can send in samples from any continent, and people already are. We are looking at about 200 farms is our target. Each farm would be sending in 3 steaks from different, same ribeye from 3 different animals, so you can get your statistical significance there. They will also be sending in the fecal material, so we can get a microbiome assay of the animals, both bacterial and I think it's RKE, genera and families. So a pretty good microbiome assay. Then they'll also be sending in the soil from the paddock and forage as well. So I guess if you're in a feedlot, you're not going to send in soil, but you would send in the grain at the feedlot. And we're going to be looking, when it comes to the beef, about 200 compounds. It looks like from the literature, the fatty acids are one family of compounds where those variations are significant, and the secondary metabolites are the other families, the terpenoids and alkaloids and phenolics, is the other area where nutrient variations are quite pronounced, that, those health giving attributes. And so it's, about $550 per steak to get it assessed. You do the math, and then, the microbiome assay is about $300 or $400, and then you got everything else. So the farmers send in all this stuff for sampling. So we look at the soil, what's in the soil. We look at the forage, what's in the forage. We look at the microbiome of the animal. Then we look at the meat, the microbes, the minerals and nutrients in the meat. So we can overlay all those data points on top of each other. And then as well, the farmers fill out a fairly long survey of, how are the animals raised? What variety are they? How old are they? How often were they moved? There's a big long series of questions there. And so that's the majority of the money. It's about 2/3 of it. 200 farms at 3 steaks each is 600 steaks, plus another 150 off the shelf that would be presumably from feedlot, because we want to be characterizing the full variation of nutrition. And most of the farmers who are signing up to join are, on the regenerative biological, pushing the envelope there side of things. So yeah, we, take all that data, and then we tell stories about it. We take the statisticians and have them run calibrations. We have scientists who review the data and come up with answers about, it looks like these are the things that would be green that you're looking for, levels and ratios. These are the things that would be yellow. These are the things that would be red. We don't know what the standard is going to be. We don't know what the answer is. We just have a process of collecting the data and engaging thoughtful people and then talking about it. So it's about $2,500 per farm is effectively the sampling cost. And then the work of running the organization and talking about it and publishing the papers and paying the statisticians, et cetera, is the other sort of $350K. So ballpark, there's your $1 million. Once we've done a couple of crops, we'll be able to tell you if that's a realistic answer or not. That's what we're projecting, but this is, again, the first crop we've decided to define nutrient density on.
Hey, Dan, we got Ramona Wong asked, would it be of value to test the bionutrient content of foods eaten by those in the blue zones who have longer life, quality of life, et cetera?
We are looking to identify the continuum, the variation of nutrient levels in food. And so we want to get the best things that we think we can find and the worst we think we can find. And that would be our 1 and our 100. So absolutely. We have been, as I said, as a small organization, only able to do a certain amount of sampling in a certain amount of countries, but the logistics of shipping soil and vegetable material from, I don't know, the Hunzas, where were they, in Pakistan? Like right now, we don't have the ability to do that on our fruits and vegetables, at least. So there's logistical concerns, but that's exactly what we do want to do. Yeah.
And have you calibrated, this is from Nicole, have you calibrated your device against energy dispersive X-ray fluorescence spectrometer? If so, can you speak to the results?
X-ray fluorescence, in short, is called XRF. And that is exactly what that was the machine we used in the lab to get the readings that we calibrated the meter to. So that's exactly what we used. where we got those numbers about the 5x or the 15x variation of minerals.
So Craig just commented, great work, Dan. The best to you with your continued research and generous sharing. I think everybody can speak to that. And thank you, Craig. Is there any other questions from the table here of our chapter presidents? Drake?
So in a certain sense, once you have this library from your test and the correlation between like microbiome and these things, you'd be able to take the produce at the store and then kind of assess the farming practices based on how it rates. Like it's almost like reverse engineering it in a certain sense, right?
What we were thinking was the more management and environmental conditions data we can provide to the farmers, the easier it would be for them to figure out. Like what we want to basically have the situation be is if you're a grower and you want to be producing the best quality food possible, and you have some data points about how your farm is doing, how your crops are doing right now, we want to be able to provide you as much guidance and support as possible to do a better job. So it's really about supporting the farmers in doing a better job. I think, I personally had the opportunity to work on farms in Siberia and Central America and South Asia when I was, 20 years ago, when I was younger, and got to see a lot of people who are on the edge, right? Subsistence farming, real subsistence farming, like you don't have any food for a couple of months, and so you're out there eating leaves. Like I grew up on a subsistence farm. I'm a homesteader, obviously with a ton of privilege as a white American male, but I'm doing this for the global commons, those hundreds of millions of people that are smallholders on land that don't have the resources to be viable in a more empowering way. I'm not sure if anybody's been to South Asia or parts of the developing world where people live on $1 a day and and basic viability is a concern. My experience being there is there's a hunger for support, for guidance. They're getting a lot of their messaging and their education from the conventional mindset, the green revolution. Chemical companies, seed companies are the ones that are doing the education of them. And while there are amazing grassroots organizations out there in some areas, like having a really well-developed data set that anyone globally can plug into and all these different organizations can plug into, my objective is to build that knowledge for the global commons so that anybody who wants to can plug in and get much better results much more rapidly. That's my objective. I think we talk about the environment and the climate and the culture. What is it? 70% of the globe's food is produced by smallholders, something like that. It's not, most food for people is not produced by big tractors on big swaths of land. Most food for most people is produced by people operating on, less than 4 acres, entirely, maybe 2, maybe a quarter acre.
There was some data that came out from a friend in Hawai'i saying that 85% of our food are grown with 15% of the world's resources from our smallholder farmers, and 15% of the food is grown using up 85% of our resources. Big agribusiness. Hey, Dan, this has been very close to my heart. Lizzie from our friends at Colorado Hemp that hold NOCO every year say great presentation. We appreciate the information. It would be great for you to present this at NOCO. Hemp is a strategic initiative of our here at HFUU, and really is important that we bring that forward to where we can honor our farmers here who grow it and be able to produce products from their land from it, because we're paradise on earth, baby. And it's like a thing we really haven't taken it out for a spin yet as far as what's possible with an agricultural system here in Hawaii, and this work will only help forward that. So I really appreciate where you're taking it to. We're at a place, let's see. So our vice president, our vice chair of the Ag House Committee, Amy, Caruso is on. She's on the East Coast. She's in DC for the Green Amendment work. So she really appreciates your work. And we have Senator Gabbard here, our Senate Chair, Ag Chair, with us this weekend. So we have our legislature represented, which is really a wonderful thing at that level.
Congratulations.
So yeah, really, we're real fortunate in that respect that they value all this. David Fisher asked, what are ways we can support your work, Dan?
In general, I say to people, what do you feel compelled to do, or which part excites you? I think certainly, join, become a member, $50 a year, order a meter, set up a house party, become an, evangelist, as a grower partner, send in samples to the labs, engage in the data collection process. I don't know that we have any grower partners from Hawaii yet. If you have access to granting agencies, or you're writing grants, and all this work takes money. So obviously, if you can get your hands on some that can be put towards it, I'm definitely very happy to talk to you. We've got chapters, we've got the science work, basically it's community education and awareness, and data collection, and it all requires funding. So in general, people have their own passions and their skills, and someone will say, you should really do this. I'm like, oh, that's a good idea. What's your like? Oh, well, actually, I'm perfectly positioned to be able to do that. I'm like, well, so then I shouldn't do it. You should do it. Tell me how you are going to help us by doing that yourself.
Right.
I see this as like, I had an idea about a way that I thought I could help affect some thing on this planet. It's a horizontal, it's an ecosystem, it's not like my work. Hopefully it's our work. And so if you feel inspired, then how do you feel inspired? I would say
One of our rockstar hemp producers here on Big Island, Cab, who asked you a question earlier, has a question for you again. Hey, Cab.
Yes, my question for you is, we definitely observe what happens in third world countries to help survive farming wise, and what's been done for thousands of years. The latest, greatest thing we see a lot of is the mob grazing with animals to help, reestablish a microbiome system. Last year we had Paul Samos talk about the EM Bokashi being the farmer's best tool in order to really help produce that microbiome that we're looking for. In your teachings and what you found, if you were going to give one tool to a farmer, what would that be? What do you see? Would you bring in the mob grazing technique so that we could really like get down to business here, or what would you do?
I hate questions like this. I would say the tool I would give you is remembering how to communicate with nature. It's, the indigenous people, at least that I understand, used to live around here, had this concept of the role of the human was caretaker. The oak does this and rabbit does that and eagle does that, human is caretaker. And so it's really case dependent. It depends entirely on what you're growing and the nature of your land and the season and the time of the season and what happened in the past, 2 weeks, 10 years, etc. It's an understanding, one is like the ability to communicate directly and discern. I like to say, people will ask me, so how do you figure out what your work plan is for the day? When I wake up in the morning, I go outside and go for a walk, and I walk around and I see who wants what done, and then I do it. And I'm halfway doing something and I'm like, something pops into my head. Oh, I think I should go over there. And so it's, to me, it's about being spontaneous, being present. You know, and I don't think I'm answering your question at all the way you wanted me to. So I can.
No, perfect for his brain. That's how he farms. Thank you.
Perfect.
So that's great.
Yeah.
The concepts are really important. Microbes are really important. Minerals are really important. You know,
Yeah.
like if you don't have boron and sulfur around, a lot of things aren't going to happen until you do. You know, molybdenum, like nitrogen fixation, you need 1 pound of molybdenum per acre for all the nitrogen fixation to occur. That would require you to never have to add compost or chicken manure or, you know, liquid fish or urea. I don't use nitrogen on my farm on principle because every plant in nature evolved the functional capacity to work with microbes to fix it. There's, you know, 3/4 of the atmosphere is nitrogen, but for that to work, you need 1 pound of molybdenum in every acre. And at least around here, it rains a lot, and molybdenum is an anion and it leaches out. And I think in Hawaii, it rains a lot too, at least in large parts of it. So depending on how the soil's been treated recently, you probably don't have enough molybdenum. And so nitrogen deficiencies may be your issue and you have to add compost, but then you really don't. So, I mean, there's just too many pieces of the puzzle to be able to say it's any one thing. It's really that it's a living system. And we can balance our intuition with our scientific Western, you know, protocols and data sets. So
What you're speaking to also is our presenter tomorrow, Ray Archuleta, our mutual friend.
Yes.
Speaks about emulating Earth's architecture. So
Yeah.
that architecture being present and how to, you know, an eagle's going to be an eagle. And like you said earlier, you know, it's just, or Joel Salomon will say, dealing with a pig and its pigness.
The pigness of the pig. Exactly. He says it so well. It's such a good call. Pigs are people, but they are who they are, right? You know, like, yeah. Yeah.
So Bob Schaefer is here in the room. He just got here from a plane got canceled this morning and had to catch another flight. So he came a little later than the presentation. But I wanted to see if Bobby, where is he? There he is. Bobby, you want to come here, sit down? You want to say, you have any question for Dan? You know.
It's a good question that Cab
Come,
presented.
you want to come? Okay, well, I know it's a little putting them on the spot, but you know, Bob Schaefer is a great agronomist and friend and is working with us closely with the soil health initiative that we're bringing forward. So it's just really inspiring to hear, you know, in your presentation, how you started off with this whole piece is that how practices affect the nutrient availability or the nutrients, how it's expressing itself on food. And tillage and all the relationships to that. Bob just did a 2-minute video that on our soil health initiative in the backhoe trench. So it's really an inspiring thing to see, and speaking to the vacuum zone, what occurs to that deep tillage, you know, not only in how it affects the food, but physically how you can see how it affects the architecture of the soil. Yeah. So very cool stuff. So in any event, we are 9 minutes away. We have 9 more minutes. If anybody has any pressing questions that they want to bring forward, Drake, you got one?
Yeah, I just have one technical question. Is there a way to reset the device? Like if it seems to just, like right now I just got an error and it was timing out on me. Is there any way to reset it, or do you just have to wait for it to time out?
When it comes to technical questions, I think I might have said earlier, I think I did, that I'm a Luddite and proud of it. You know, we do have a technical team that answers questions. There's a regular scheduled call every Tuesday for people that have questions. And then certainly, if you got one of the meters, the connections like should be in the box, like send this email, you know, go to this meeting, and stuff's on the website. I'm really, I don't download apps. I don't, you know,
Well, you know, with that,
I'm not the one to talk to about the logistics of making it work. Let's just put it
right
yes.
on. And with that, Drake, when I brought the meter to this just arrived the day before we came to yours, and so I brought the meter to Drake, knowing that he had an Android, and knowing he's just got the mindset for making it all work around that, all the technical issues. So it's great that he's been able to calibrate it to where he's at, and he'll get to share it now from a different point of view than first receiving it after hearing the presentation. So it's great. Sue's got a question.
Where or when can I get one of these?
Where or when can she get a bionutrient meter? You go to bionutrient.org,
Yeah.
the website, and you can order it. It took a few months to get mine, but that was because of production.
We're constantly back ordered, and the whole thing with chips and various car companies
Right.
can't cars, like, it's got chips in it. So I think we've got 140 new boards coming in the next 6 weeks, and then I think maybe 30 or 40 of them are ordered. And then when those are out, I'm not sure when the next batch is coming in. So
Well, your
Yeah.
whole open source approach to it and working with the commons is so right on, because air, water, and food are our commons.
Yeah.
And it's something where not having this co-opt by big ag interests is essential. And so thank you so much for your leadership in that respect, and your vision. Really appreciate where you're coming from with this. Anybody else have any questions? Annie?
Yeah, really great to catch the.
That's our vice president.
By the way, you're speaking to this mic, so you gotta enunciate.
Okay, so I'm looking to hear it.
Yeah.
So great to hear you. You mentioned a little bit about potential funding sources, and one of the things I would love to see is the possibility of, if you could send our way any places that could be potential or interested in the work you do, to have our organizations do something together. I'm pretty experienced in writing grants.
She's batting 1,000.
So we could take a look at some of those and where the two organizations can come together. I'd love to explore some of that. If you could just point me in the directions of potential areas or potential sources.
Maybe Vince can set up a call and we can do this offline. I would be happy to. I mean, collaboration is foundational to our whole ethos, and if I can whatever the word is, inoculate an organization in an hour and a half and have a long-term relationship afterwards, this is a wonderful use of my time to establish that symbiosis. Absolutely. Yeah.
And Jerry used to say, nature only wants to collaborate and cooperate. So it's good that's what we take on too. We have 5 minutes left, everybody. So please jump in. Yes, Matt Dreyer is our president. Come here, Matt. Sit next to you. Is our president of the Hawai'i chapter. There we go.
Hi, Dan.
Hey.
I was just texting one of my chapter members, Janet Boggs, and she said she knows.
Doctor.
She does, yeah, Dr. Janet Boggs. So she does the same kind of work. And you had so much information, so I might have spaced out because my mind went in different directions while you're talking. So we might have covered this already, but can this device be used to measure the nutrient density in soil?
Well, what is nutrient density is the first question. It's a word that people are starting to throw around, like regenerative, which also has no definition. So, can the device be used to test nutrients and carbon and things like that in the soil? Yes. Right now, it is already calibrated for organic matter, for carbon. So like to within 0.5%. So if the reading it gives you is 4, like we're pretty damn sure it's between 3.5 and 4.5. So anything in chemistry is a vibration in physics. And so just like I was saying about testing the water to do point source pollution identification as citizen science collective, like we want to figure out what's going on in our environment. Yeah, you can test the soil just as easily. And whether it's this meter or future ones, the point is the capacity to do this with a handheld meter is technologically there. All the things that a smartphone can do, it's remarkably small and it can do all kinds of things. What if you can test one thing, you can test many things. And it's just about building the calibrations and having the meter engineered in such a way that it can identify this or that, because certain things vibrate at different frequencies. So there's some technical details there, but on principle, 100%. On principle. Yeah.
Julia McCormick, one of our attendees, who hopefully is if she's not already a board member of one of our chapters, will be. She says maybe every chapter should have at least one meter, and members can bring the items to test at meetings. It's a great idea, Julia, and make it so, Julia. Help to make it so, yeah. And
I
then
think
we
that's
have.
part of what we're planning on launching in the next month or so is these house parties globally with people who have them all over the world and saying, okay, now you've got one, who wants to bring their friends over, and you bring your shopping from that store, you bring your shopping from that farmer's market, you bring your farm produce, and we'll get together, open a bottle of wine and flashlight at food. And if we really get excited, we can take some of those samples and then send them off to the lab to, but doing, community organizing, awareness raising, movement building, grassroots, symbiosis with the organizations that are already on the ground. I mean, this is the only way we're going to succeed. This foundationally could be perceived as profoundly threatening to the status quo, right? And there's going to come a point when a lot of vested interests are going to say, really, this is not in our interest. And so, we will only succeed with this endeavor if we are grounded in the grassroots through things just like that. So 100%, Julia.
Well said, and a great way to end this session. Drake has one more question, and then we'll check out here. Thank you.
Yeah, my question is right now, because we have deficiencies, if you put the meter, you'll be able to determine these deficiencies. But once you have like sufficiency in your soil, will it just be vibrating on all the spectrums?
How do I answer that question? If the meter you've got is calibrated to be able to test copper and zinc and cobalt and molybdenum and molybdenum and chromium, vanadium, if you have sufficient levels of all those in your soil and the meter is calibrated for that, it will give you that response. I don't know if it's just the minerals. I think there's the organic matter and there's the microbiology, and actually the microbiology seems to be able to make minerals if it needs to. We don't talk about that very much. Some people do. And microbiology fluoresces, and they're actually not too hard to see, different families of microbes. We haven't really gone down that rabbit hole yet, but we understand the critical role of microbes.
Probably about 5% of what we know in the soil right now, I think, is with.
We've got names for 5% of the species. We understand them all. We've got names for them. It's like dark matter. 95% of the universe is on a frequency range we can't find with any machine we've got, right? Most of reality is somewhere we literally can't find with our Western externalized scientific instruments. I would suggest that that this instrument, this body we've got, is wired for many, many octaves of perception. But maybe end on that conversation.
I'm sorry, but well stated though, and I hear that. And I think everyone gets that message and appreciates where you're coming from, Dan. Thank you so much, brother. It's been an enlightening.
It seems like a wonderful group. Yeah. Be well. Thank you very much.